Hey, hi everyone, welcome back to today's video. Hope you are doing great, all are going good. So today we are going to understand, or we are going to learn about MPLS L2 VPN, point to point BPWS. Already we have covered. Now today we'll cover point to multi-point BPLS. This BPLS service basically provide point to multi-point and multi-point to multi-point, which is fall under MPLS L2 VPN. Now already we have covered point to point BPWS service. If you have not watched it out yet, I would request you please click on the I button. From there you just check it out. It would be helpful for you to further understand. Now let's focus on the VPLS, right? So here I again like other video, I have break the complex thing in easier way for this VPLS. So let's understand the VPLS. So what is VPLS basically? VPLS is nothing but a virtual private LAN services. It's a class of VPN that support multiple site communication, L2 communication basically over the MPLS network. As I said, it support point to multi-point and multi-point to multi-point. Now I will explain entire this VPLS following this diagram, wherein I have explained basic MPLS network, right? Wherein PE router is there, CE router, and there is two client. Let's understand, or let's assume that this client left hand side is located in Delhi, and right hand side client is located in Bangalore, right? Now they wanted to communicate each other. So this is over the L2 communication this basically they expected. Now in VPLS, how it helps to achieve, right? So VPLS service act as a L2 switch. Now this VPLS service will make your MPLS entire network as a L2 switch. Now these two client will feel like they are connected directly towards a L2 switch, because this communication gonna happen over L2 only, right? But hope you remember in BPWS I have explained there two client is connected directly over the cable. All right, so in BPWS there is no MAC learning, right? There is only forwarding. But here BPLS, it's act like a logical switch. Here MAC learning is happen, and based on that forwarding happen. So BPWS act like a hub, and BPLS act like a L2 switch. All right, so let's understand a bit more, right? More detail. Now already you are a bit aware that all this configuration part, all this play around part we do, right? Or your service provider does in your PE end, right? Provider end, right? So we'll focus the provider end router, right? Every mechanism, every configuration, or everything is in this router basically to bring out or to bring up this L2 communications, right? So let's focus, or let's enter into this PE router, right? Now we are in PE router. Let's understand what happened and what this VPLS service does for this L2 communications. First, I explained in BPWS that we take a sorry, we take a help from someone which will help us to connect a logical wire, since it is a logical connection. But here in VPLS, someone we need a help which will help us as a logical switch, right? That is what first concept comes here in this router, that is bridge domain, right? All right, now what is bridge domain basically? Let's understand this part. Bridge domain is nothing but a single broadcast domain. Bridge domain nothing but a logical switch. Bridge domain is nothing but a VLAN, right? So already we are very much familiar that we do create multiple logical switch into a physical switch, that is called VLAN, right? So VLAN is nothing but a single broadcast domain. So you can understand that way, bridge domain, broadcast domain, or a logical switch, or a simple VLAN. That's it, right? Now here this bridge domain also maintain MAC table, right? So it also maintain, it's learn, it's do forward based on the MAC table. Now here bridge domain is fine. Let's say bridge domain we have created, right? VLAN we created, but what about interface? Who will help us to connect these interfaces, right? For that, again we have to take another one help, right? Who will help us to connect the interface, right, within this bridge domain. Now service instance is the concept or the mechanism through which what we'll do, we'll create a separate isolations for this client only, for this site only, for this customer only, right? So once we create this service instance, basically I would say, or you can understand that way, I would say it's a interface. It just help to map this interface which goes to your client, right? It maps to the service interface in service instances, and this service instances map to bridge domain, right? So service instance under your bridge domain. Now this service instance, you in BPWS, you seen that there is a attachment circuit, right? Now this here the service instance understand what kind of topic I'm going to receive, right? So hope you understand. So this is the, let's say this is the interface G0, right? This interface map to the service instances, right? And this interface and the service instances map towards a bridge domain. They are part. So let's understand that way. This service instance is an interface which is dedicated or which isolate a interface towards your client, right? Which is maps to your client. Very simple, right? That is what I break the complex thing easier way for you, right? Now that is fine. This guy is connected directly. For that we need a service instance. We know the interface, right? It is directly attached for us with us basically. So it's easy for us, right? Now what about other interface which is very far from us, which is located in different location altogether geography, right? So in that case, we will help us to map that interface. In that case, another concept we have to introduce, that is the VFI. What is VFI? Virtual forwarding instances. Now these instances will help you to forward or to learn the MAC address. Now what is happening here? Let's understand. Very interesting topic. This is the basic concept. First, I'll try to focus this concept first. So let's say this is your client. It is connected to your service instances, right? So this bridge domain connected to this, right? And another is connected to other locations, right? So in that case, this VFI will help us to connect other interface which is physically connected to other location, geographic separate locations. All right. Now here one interesting part. If I forget about this VFI part, if I connect another client, right, or another router, I would say, or a switch, I would say, and if I make this member of the same service instances which is fall under the same bridge domain, in that case these two client, right, can communicate within themselves a L2 communication, right? So it's a purely logical switch we are making, the using of bridge domain, using of service instances. All right, but still we have not clear yet about that VFI part. Now how this VFI part work, let me clarify this, right? So like we created one logical switch, service instance, virtual forward instances, both that we have created, right? Now the similar way we have to create other PE, which is Bangalore, right? So in that router, again we have to create one bridge domain, one VFI, one service instances, right? Now the service instances will be mapped towards your client, right? Now here what will happen, this VFI, since this service instance no directly connected this interface, so it's know this interface, but this VFI doesn't know where is other interface. In that case, this VFI need again or someone else, that is the one logical connection is needed. How this logical connection get established, right? Over the TLDP, right? So over this another TL, through using another TLDP, it's established a connections VFI to VFI, right? So here what happened, pseudo-where help is needed, right? Again we do take a help of pseudo-where which help us to map this VFI towards other interface. So here service instance map to a physical interface, that is a map to the logical instances. All right, hope it is makes sense, right? And this VFI or this service instances collect or learn the MAC addresses, right? The service instance learn the MAC address of this client, so he will enter over here. Now this VFI will learn the MAC address of this client, again it will enter over here. So to MAC table, it is going to enter into this breeze domain. Now this logical switch having two different MAC address, through that it will forward the packet. Now once this pseudo-ware is established over the TLDP, right, what happened? In that, then on top of that, it will establish a L2 VPN, all right, and through that your L2 traffic gets travel, right. Now thing is that how this traffic or how this packets looks like if I capture, right, how would be the header, since your MPLS network is in between in your switch, right. So let's understand that part. So if I maximize or if I elaborate the L2 data, how it looks like, let me explore. Yeah, the data part or header part, it looks like this. I already explained the labeling part in previous tutorial. Please watch that out, as I said, in BPWS tutorial. So from there you can understand the tunnel level and VC level. Tunnel level, let me clarify this part. Tunnel level is not work in this your MPLS network. Your entire MPLS network, it may be 1000 router, it may be 100 router, all look out this tunnel level, right. It's just look out the tunnel level and then it switched the packet towards second level. After that, once this router received, mistake, it's my bad, this router, right, once they received, he will check the VC level, right, because in this router might be there is multiple client could be connected, that is multiple client could be connected. So based on this VC level, packet level, it will forward accordingly. So like your I would say L3 VPN, right, bottom of stack, I would say the concept again comes into the picture. Top level and bottom level. Top level look out in the MPLS network, VC level look out in the edge router end, right. Then there are two type of header. One is the inner header, which is actual. This L2 header comes with a source MAC and destination MAC. Source MAC is belongs to this client, and destination MAC belongs to this client. The same way L3 header as well. Then come into the picture the payload. So this is the inner header. This is the actual packet, I would say, and outer header consists with your level and the L2 header of this MPLS network. All right. Makes sense, right? Now hope you understand the breeze domain, hope you understand the service instances, though I am going to text this thing as a definitions, I would say. So you are creating one breeze domain. Within that there is service instances which is mapped to your physical interface, and you are also creating one another instances, that is BFI, virtual forwarding instance, that is mapped to your logical interfaces, and that helps you to bring of your logical switch, right. Now here this breeze domain will maintain one MAC table. So altogether this entire MPLS network act as a L2 switch, logical L2 switch, right. Hope makes sense, right. Now let me take you to the lab, wherein I'm going to explain all how to configure all the configuration part. I will capture the packet, all the stops. So let's go into the lab, right. Here you go. So this is a very simple lab wherein you can see three CSR as a provider edge router, and there are three different geolocations, physical separated, and one is let's say Mumbai city, another one is the Kolkata city, another one is the Delhi city, and these three locations are in three different physical locations, I would say, and they wanted to, or this customer wanted to communicate over the L2 basically. So this is the expectation from the customer, and that we have to provide as a provider. All right, and that I am going to explain. Now here I would like to highlight another thing, that here few things are pre-configured. So what is pre-configured? So this MPLS network, you can see, right, in this MPLS network this core IGP is already pre-configured, that is the OSPF, that I will also show you. Another one is the MPLS part, right. So basic MPLS part. So let me take you to the router first, so that I can show you. Here you go. Hopefully it is visible for you as well, right. So IP neighbor. So you can see, let me make it bit. Yeah. So here you might observe, what happened? Just a minute, it's my bad architecture. yeah. Okay, now we are in which router? CSR2, right? And it is already IGP is pre-configured, OSPF is already established with whom? With this MPLS core router basically. So this core router could be multiple router, right? Here I have given the example with the single router, which is taking care of the MPLS part. All right, so MPLS is already the IGP part is already ready, and MPLS part, as I told you earlier, that is also ready. You can see multiple labeling is there. So MPLS part is ready for you. Now only thing is that we have to configure the BPLS, right, which is our objective today. Now before that we have to understand, as we understand in example, right, first we will create a logical switch, that is the bridge domain. So let's go. So we will enter into the configuration mode first, right? So here we are here. So first we will configure the bridge domain, the logical switch we have to configure. You already remember, right? Just a minute. So let's say one bridge domain ID we have to mention over here. Let me show you with the question mark, so that you can see. Let's say I am going to use this bridge domain 101. This is the ID basically, right? So we have configured the logical switch, so we are done. No, it's not like that. So apart from that bridge domain creation, we have to configure the service instances, right? So service instance, to configure the service instance, we have to choose the one interface. Which interface? Where our client is connected. So here interface is the gig2, right? So let's enter into the gig2. Let me exit from here. Sorry, interface gigabit 2. Here you go. Yeah, now we are into the interface basically. Now what we'll do here, we'll create or we'll map with one service instance, right? Very easy. Service instance, again we have to put one ID. You can put a help mark, and you can see that any service instance ID you can put. Right here I am putting for 1111, and it is definitely Ethernet, right? So this isolation we have created, and we have mapped to the interface which is connected to our customer, right? So what we'll do after that, we will configure the encapsulation. Why we need to configure the encapsulation? Because we have to understand what kind of traffic we are going to receive. So encapsulation type is multiple type is there. As you can see, default.1AD, .1Q, private tag, and untag. If you want to receive the untag traffic, we will configure the untag. If we receive the default means any traffic, we will configure the default. But here our plan is to basically receive to .1Q means tag traffic. So let's say it's a 10 or VLAN 10, right? So what happened? So service instance we have configured. We mapped the particular interface where the client is connected, and that we are we have pre-configured that encapsulation .1Q, since we are going to receive our .1Q tag traffic, right? Now what left? Only one thing we left, that is the member of bridge domain. We have not put this interface into a bridge domain what we have created recently, right? So let's put it this way, bridge domain 101. That's it, right? Done. Let me save it, commit. Here in this IOXE it is commit always. Without commit it will not allow you to get exit. Yeah, so service instance configure. So let me get out from here. Yeah. So let me show you one thing. So you can see, right, this interface we have make a member. Now this is part of one switch. Now we should show, or we should see the switch. How we'll check the logical switch? Show bridge domain. Bridge domain is our logical switch. This is how we will basically understand, right? It would be easier for you. Yeah, so bridge domain 101. So what is showing? Nothing is showing, right? There is no MAC address at all. It is only showing this interface is part of the service instance 111 as we have configured, but there is no MAC address. So to do that, to show you, let me show you. Let me show you. Just give me a moment. So I will initiate one traffic towards here. Towards where? Towards our CSR. So I'm going to generate one traffic from Mumbai towards our edge router. How I'm going to generate? Let me show you. Just a moment. Since I don't know where to reach, I'm doing. If I could initiate one broadcast, it would be enough to initiate the traffic. Now hopefully MAC address get learned, right? In earlier output you have seen or you have observed that there is no MAC address at all. Now once I initiate the traffic, immediately it's learned the MAC address, right? So you can see MAC address, right? So what is the policy? Forward dynamic. What is the aging time? MAC address has, as we know, like aging time is there, right? For CAM table or MAC table here, right? Now here, this is the very important part, pseudo var port, right? So which port we are making a pseudo var port? That is, this is the interface, right? Now what is that? Ethernet flow point. Here we are not using Xconnect, we are using Ethernet flow point 11. It's nothing but a service instance. You can see, right? 111. So it's a service instance, right? So what it proves that here you connected, this router is you're connected to your bridge domain, and your bridge domain is learning this MAC. All right, and this proves this MAC address belongs to this interface, right? Which interface? This interface, this gig2 interface. And how it gets learned? With the service instance, what we have mapped with this interface basically. So altogether this interface part of the bridge domain 101, and this interface is also part of the service instance Ethernet flow point 1111. Service is nothing but a service instance. All right, and we already learned the MAC address. Now one thing you might see, whose MAC address is this, right? So let me, oh sorry, yeah. So here you can see we have make 1.1 sub interfaces where we have configured this IP. This is the main interface. So interface gigabit include BIA. So you can see this is the MAC address. All right. So whose MAC address? CA07 in last 0001. The same. Just a minute. Yeah, you can compare like this way. 000007, this is the MAC address, or the BIA or one in address is this, right? You can see the same address, right? So it's learned the MAC address which belongs to this interface. Very simple, right? I'm not putting more trace, otherwise it will waste our time. Now thing is that if I put another switch or another client over here and connect to the same service instance, same bridge domain, automatically they can communicate within themselves with learning MAC address like this way, right? So what happened? Now our bridge domain is configured, service instance is configured, now one interface is tagged, service instance part is done. Now what about other part, virtual forwarding instance, right? So before that, let me switch on this router. Otherwise it will be messy. Yeah, so this is router is not needed now. We have to log in this router. Okay, now what we'll do, let me minimize this part a bit, otherwise it takes much space, right? All right, so far what we did multiple things, but we have not configured is the VFI, right? Now the time is to configure VFI, right? So let me show you how to configure. I'll be a bit faster, right? Otherwise it takes time. So how to configure the VFI, other interface, and we have to map to the bridge domain. Again, it is very simple, right? VFI L2 VFI. Let's say I'm putting the name of the VFI is what is that? Customer 1, right? Customer 1. All right, and it is the manual. Now before going to manual, let me show you one thing. Without manual, you can configure the point to point and other auto discovery, all this part. Since our underlay is the IGP MPLS, we are not going to configure the auto discovery, something like that. So we'll configure it's a manual will say tell you the which one is the neighbor annual, right? Yeah, so customer one, yeah. So VFI is already created. Now what we have to do, we have to configure the manually, we have to make the member of the bridge domain, right? But before that, we have to remember that VPN ID is very important, which will identify or distinguish your virtual private network what we are building, right? So VPN ID need to be configured, that is 1111, right? All right, let's say I put this number only. Now what left? Now make to bridge domain. Okay, bridge domain. All right, what bridge domain we have created? 101, right? Now it is member. Now the main part, this is very important part. What we have to do, we have to tell this router, we have to instruct this router, basically it has to do that your member, right, your VFI interface, the other router, which interface? Again, it will be logical interface, right? So it would be neighbor, since we choose the neighbor manually, right? So then who will be neighbor? I have not show you though. The logical interface, the loopback interface is the 333, this CSR3, and 111 for this CSR1. Now we have to configure 111. Again, encapsulation, which encapsulation it is MPLS, definitely, right? All right, this is, I have instruct this router, go there, go to CSR to map your VFI, right? And who another would be the neighbor, that is the 3.3.3.3. Now you might think whose IP is this 3.3.3, which I have not show you. This CSR3 loopback IP address is 3.3.3, right? All right, commit completed. Okay. Now we have to showcase everything, right? We have to verify all these stuffs. First, let me show you one by one. So bridge domain 101, right? So again, traffic not initiated, but another thing here you can see the VC ID, the VPN ID basically mentioned over here. The VFI you have configured, the neighbor is this. So this is also part of this bridge domain. That is what earlier it was not there. Now it is there because we mapped this VFI into this bridge domain. Though there is no MAC address, right? Why there is no MAC address? Let me again tell you. So another thing is that this router IP is 172.16.1.1. So let me log into this router. From here I will try to reach over here. Where I will try to reach? I will try to reach Mumbai. Oh, sorry, Delhi. 172.16.1.1. Though all the thing I have configured there previously. I have initiated one ping. Yeah, it is reachable. You can see automatically will come. Yeah. Oh, great. It is done. Congratulations for you. Now you can understand this is the MAC address. Already I have shown you this is the MAC address we learned, and this is the MAC address what we learned from where? From the customer one who is there with the VFI, right? So how it is learned, let me tell you. Whose MAC address is this? Delhi's MAC address is right. It should be IP interface brief. So which interface? Basically it is this interface. All right, so interface include sorry, how come multiple interfaces is there? Here you go. Oh, sorry. So here I missed one thing to put this specific interface basically, though you can check in just a minute. Yeah, you can see this is the MAC address. Whose MAC address? We have learned where this router, right? You can see 39, right? 39, where it is? Here it is. How it's learned from the customer 1 VFI. It's this previous MAC address learned directly connected Ethernet flow point, right? It's a service instance, and this is the interface for the VFI. We have created the VFI with the customer name CUS1 customer 1, right? So from here it is learned whose MAC address is this. This MAC address is your Delhi router MAC address, right? So this bridge domain build your MAC address, MAC table basically, and where it is belongs to, there is pseudoware interface mentioned under that pseudoware port, pseudo port basically. All right. So it makes sense, right? Another thing is that now let me ping from here to Kolkata as well. So where we are, let me do that. Okay, so let me ping from Kolkata to Delhi. Ping 172.16.11. Yeah, it is reachable. So IPINT with which interface it is. This is the interface 3, right? So run. Oh, sorry, it's my bad. So interface, this is the interface, include BIA. So this is the MAC address, right? Now who should learn this? This router should learn both the MAC address. Now let me show you that as well. Please bear some time, it takes time. So bridge domain 101. Here you go. You can see the two MAC address you already learned. So from one pseudoware customer 1, this is the pseudoware port, right? So basically this is the VFI, and this is the pseudoware Ethernet port. So this guy learned two MAC addresses, Mumbai and Kolkata. Sorry, excuse me. All right, now main part we'll check, that is let me take you to the this router. Now here what all we'll test, which is most important. So MPLS L2 transport VC. Now here you can see this two tunnel is up, right? Two tunnel. One is the VFI customer 1 with the pseudoware. This goes to Delhi, and this goes to Kolkata, right? So two VC circuit is up, I would say. Likewise, you can test everything, right? Another command you can check how basically it is working, I would say. So L2 VPN, something like that. Even I forgot. L2 VPN service instance, maybe service. So MPLS L2 VPN. Let me put it in just a minute. VFI. Yeah, here you can also see there is two pseudoware, there is another pseudoware, and their neighbor is this. Now what will happen, let me show you quickly, because people's patience is very less. Now what I'll do, I'll ping from here, and I will capture the packet to check or to understand the what. Yeah, but before that let me capture packet from here, this interface, right? 1/2, the header part. 1/2 let me start this capture. Yeah, another one I would capture from here as well. Oh, sorry, capture gigabit 2. Remind me later. So this is going on. What I'll do, I will initiate one traffic. Let me initiate, let me stop to analyze. All right, let me stop this also. I will go here later. So here is ping. So try to understand from here. This customer, this locations wants to reach these locations, right? And it is travel via this path CSR1 and CSR2, and I have captured this packet in MPLS core here only. So let me analyze this first. So this is your ICMP, right? Let me elaborate this port. It is very important and very in terms of, let me show you, in terms of this header, right? So here header, you can see Ethernet header, multi protocol level switching MPLS. There is the two header, right? Two level basically, level 16 and level 17, right? So level 16 is the first level, it's a tunnel level, and second one is the bottom of stack, right? So bottom of stack means like a very bottom level, and you can see bottom of stack is 1. This is the last level, it is the VC level, right? So two kind of level it is mentioned in the header. And then ICMP protocol, this is the payload, this is the L3 header, and this is again L2 header, right? Source and destination MAC address. This is the actual header, actual MAC address, source and destination. So who is the source and where to reach. This is the final one. So I'm trust me, I'm not explaining much, because I already explained in previous BPWS much, and let me, I try to quickly close this, because here you can see only one, bottom of stack 1. So this is the last level 16, and this is being received by this guy. So there is two level, one level already here popped, right? And the last level, bottom of stack, the level 1 going to receive by this router. So this is how basically you can understand how this entire bridge domain work, and how this service is configured, and how this purely L2 communication happen. All right. So hope it makes sense. I hope you understand this header part of why two level, why all this stuff, right? All right. Thanks for your patience. Thanks for your time.